everyone, welcome to Learn. I'm here with Albert today. I'll be keep going with our discussion on nuclear fission. So for today, we're going to be evaluating on the pros and cons of nuclear fission, and we can start with something that everybody might know. Fukushima and Chernobyl. In 2011, March 11th, citizens living in Futaba district, Fukushima, heard a heavy bombard sound coming from the shore. It was a Unit 1 of the Fukushima nuclear reactor. This nuclear reactor have just undergo through a nuclear meltdown, in which the core of it, or the fuel rods we talked about last time, melted into radioactive substances, releasing toxic gas, so it has hydrogen that can explode, which is probably why the entire place exploded afterwards, while releasing heat through radioactive decay, heating up the entire primary circuit, turning them into steam, and therefore pressurizing the entire chamber of Unit 1. Causing the later on explosion. This was caused by a tsunami that struck the station about 15 minutes after an earthquake, and a failure in the design of the seawall that was intended to block only waves under the height of 5.7 meters, while the tsunami reaching 15 meters almost flooded the entire station, causing a loss in DC power in Unit 1 and Unit 2. This later on resulted in the lack of cooling water as well as overheating in the entire core, causing nuclear meltdown in reactors 1, 2, as well as 3. Now, let's go back for 25 years to 1984 at the city of Chernobyl, in which the Chernobyl nuclear reactor, the Unit 4, was going through a controlled power down and will be going to experience an electrical test afterwards. As a test for the voltage regulating system, the entire emergency core cooling system for the Unit 1 power plant should be shut down, where the power output must be reduced to lower than 1,000 megawatts. However, due to some shift change issues, the power plant kept producing energy without an emergency cooling system for more than 11 hours. This led to some serious issues when the electrical test actually began around midnight. This resulted in a series of explosions in Unit 4's power plant, releasing a huge amount of radioactive gas into the atmosphere and shining through the entire night sky through an explosion capable of being seen at the nearby town named Pripyat, around 3 kilometers away from the Chernobyl nuclear power plants. Just like what the machine operator in reactor number 4 stated, the sky was colorful and bright. I saw orange, red, and sky blue. It was red as blood. It was a colorful rainbow, and it was very pretty. Okay, now let's look at this pyramid. It categorizes all the nuclear accidents from level 0 to level 7 based on their severity. And for example, there has been only 2 level 7 accidents, Chernobyl and Fukushima disasters, both of which were introduced in the video. And there is also one level 6 accident, 4 level 5 accident, as well as 9 level 4 accidents. And basically everything below here, level 3, 2, 1, and 0, is not that much, serious, but still they're considered to be accidents in which they could still impact people's life. Now you've seen what nuclear power can do, but what about other types of energy sources then? So it is better to take a look at this graph over here. As you can see, the y-axis of this graph represents different types of energy sources, such as coal, oil, and of course, our nuclear power. Well, on the x-axis, you can see it says mortality rate in deaths per 1,000 terawatt hour, which basically tells us that the longer this blue line is, the more people this kind of energy kills, per unit their energy produced. So as you can see, the nuclear power clearly ranks at the very bottom of this graph, since its blue line is, clearly shorter than the others. So what's been showing this graph is pretty straightforward. As you can see, nuclear energy has been saving lives and preventing deaths comparing to some other types of energy. Also, according to NASA, even if you count the casualties made from Fukushima and Chernobyl, nuclear energy has also saved, from 1976 to 2009, 1.8 million people. And that's a pretty big number. And why do nuclear energy save lives? It's pretty simple, and it's because nuclear energy never contaminates the environment. Nuclear energy is essentially a clean energy in which, well, not much radioactive material is being exposed to the outside environments as all of the nuclear wastes are being, well, at least kept somewhere. Also, nuclear energy does not produce any CO2. Unlike other types of energy resources, probably apart from wind, like burning coals or gasoline, there is no CO2 being released in the atmosphere in any of the nuclear reactors, actually. And that is really good because nuclear energy does not contribute to global warming or climate change, and yes, they don't. However, if you ask any of the scientists or engineers about whether nuclear reactors are good, they might tell you that they're not technically elegant, meaning that they're not really effective enough in using up all these energies stored in the radioactive materials, such as uranium. Now that you may be wondering, then how do we use these materials to their full potential? Well, let me tell you this. Sometimes you don't have to split a heavy nucleus into smaller nuclei. It is actually possible for you to combine or fuse two smaller nuclei to a bigger one. And that is the content for our next video, nuclear fusion. See you next time, and thank you for coming to Turtle Learn.